Good. So as I mentioned, what I'd like to do in this first presentation is really set the scene. We're going to talk about why wood, particularly in terms of sustainable low embodied emission building materials. And then I want to give you an overview of the different types of engineered wood product systems available here in Australia and how they're supplied. So we'll cover lightweight timber frame systems, mass wood frame systems, and mass wood panel systems. So this question, why wood? Look, we're all building professionals. We all use a wide range of building products: steel, concrete, aluminium, brickwork, and of course, timber. And all of these products have one thing in common. They come from our one earth, and we really do only have one of these. And look, reality is in sort of first world countries like Australia, we really do produce a lot of materials. We probably need, the pundits will tell us, 3 years to actually provide the sort of consumption that we do at the moment. And that has an environmental impact in a range of different ways. But I guess the thing that's taken the focus globally is this impact around carbon dioxide or CO2 emissions. And the building product sector is an important sector in terms of its environmental impact. Uses around 12 to 20% of water consumption, 25 to 40% of energy use, produces 30 to 40% of greenhouse gas emissions, and 25 to 40% of solid waste generation. It's interesting when we put some of this greenhouse gas emission in perspective. The airline industry is often sort of bagged a little bit for its emissions, but it only produces around 1% of global greenhouse gas emissions, shipping 3%. The cement and steel sector alone produces 12% of global greenhouse gas emissions. So how we build is really important. And definitely in terms of the sort of a friendlier way we can do it, the use of bio-based materials such as wood is certainly a good option. As we know with wood, it's natural, renewable, biodegradable, recyclable, sustainable, and greenhouse positive. So it's definitely got a lot going for it. You probably remember back to your high school science and the concept of photosynthesis. So what our forests and our trees do is they take that CO2 in the atmosphere, and using the solar energy of the sun, those leaves break down the CO2, they release the oxygen that we breathe, and they store that carbon in the woody mass of the tree. So about 50% of the dry weight of wood is carbon. So by example, if we use a hardwood that has a density of around 1,000 kilograms per cubic metre, around 500 kilograms of that is carbon. And if you multiply that by 3.66, that's how much CO2 is stored. So we really have a good story when we look at this sort of timber and carbon cycle. As we mentioned, the forests are very greenhouse positive, sequestering that CO2. In terms of the production of timber, for most of you who've been to a sawmill, you'll see that they don't use a lot of embodied energy, very minimal amount of pollutants during processing. If we compare timber with other alternative materials, competitive materials, you can just see quite clearly by these graphs how much CO2 is released. And again, if you take into account the fact that those forests are storing that carbon, we really get a sort of very different aspect compared to other materials. But the other thing that people often overlook, but important to remember, is that those timber products continue to store carbon for their life. So if they go into a house, that house might last for 50 years, 70 years, 100 years, I don't know. There's plenty of timber buildings around the world over 1,000 years old. So as long as those products are being used, that carbon remains stored. At the end of that first life, when we deconstruct the building, we can do a couple of things. We can either reuse the products directly, like timber flooring or windows or doors, or we might sort of recycle that into some completely new type of timber product. And if at the end of the day we can't reuse or recycle it any further, we can do two things with that timber. If we actually store that timber in a landfill where there's no oxygen, that carbon will remain stored forever. It needs oxygen to biodegrade. But we really probably don't want to be sticking things in landfill. A better solution at this point in time, if we can't reuse it or recycle it anymore, is to actually burn that wood as a cogeneration fuel. So displacing a non-renewable fossil fuel like coal and using a renewable fuel instead. And that CO2 that's produced that goes back to the atmosphere is then reabsorbed again by the trees. So we get this really nice carbon cycle where the carbon's just cycling through different types of applications. Now, there's a massive interest at the moment in the embodied impact of materials. As you probably know, the federal government's got a net zero by 2050 policies out in place. That's their aspiration. And there's whole different groups are trying to sort of work out how they assist with that. Certainly building is a big area. So the building ministers met just last month, and they've actually all agreed that by NCC 2028, they want to include in that embodied emissions materials impacts of building materials, which is really fantastic. And that'll happen probably in the commercial sector through neighbours and the tools that they've got, and at the residential sector through the NatHERS scheme that we use at the moment. And I'm sure a lot of you are aware, if you're interested in this area, that there's a whole range of other organisations, the Green Building Council, ASBEC, a whole lot of voluntary organisations that are also very focused on embodied impacts of building materials. You're probably also, a lot of you are aware of MECLA, the Materials Embodied Carbon Leaders Alliance, which has brought together all of the major companies really in that commercial and a lot in the residential sector to focus on driving down reductions in embodied carbon in building materials. And they have a series of different working groups. And one of those is actually the specific one looking at engineered timber. So if you're interested in this, feel free to join up. Also, WoodSolutions has got a number of good documents you might be interested in here. So Technical Design Guide number 55 in particular, I'd encourage you to download. And if you want some more information around carbon and forests, FWPA have also got a number of good documents there, all available from the WoodSolutions website. If you're a bit of an embodied emission aficionado and you want to get more information about it, WoodSolutions also has now a database of all the timber-related embodied emission data. So they pulled that together from all of the different environmental product declarations and put them together in one source. So please have a look at that too, also, if you have any interest in this area. But look, really is we're looking at new systems and new opportunities. It really is all about engineered wood products going forward. And this is a nice little quote from Alastair, who was head of the School of Architecture over in London. If the 19th century was the century of steel and the 20th the century of concrete, then the 21st century is about engineered timber. And this interest in embodied emissions is really driving a lot of this interest at the moment. I guess at a sort of high level, we can sort of separate our engineered wood products into these 5 different categories. Those produced from solid wood, veneers, strands, particles, and fibre. With our solid wood products, which tend to end up in things like our framing material, beams, columns, those type of applications, maybe the lightweight area. And then we also have our mass timber systems. Under our solid wood products, obviously our machine graded pine, which is used in probably all our sort of lightweight timber framing. And every stick of this is really engineered. Like every stick of timber produced goes through a proof testing machine before it's stamped and graded and sent to the marketplace. That MGP in its sawn form can then be used by the frame and truss sector to produce roof trusses, open web joists, those type of things. We also use that type of product to produce bigger materials such as glue laminated timber, or even use it in things like I-beams. And then with our mass timber products, it's not just about CLT, there's also other things like nail laminated timber. And I'll cover a little bit more of this shortly, but our other speakers are going to certainly talk about some of these different products that are out there. With veneered products, our main one, I guess, from a structural sense is laminated veneer lumber, where we can get that's produced in sheets up to around 1,200 metres deep for billets, so we can cut all different sizes out of that depending on the application. Also these days you can get cross-banded laminated veneer lumber if you're using it in big panel sections to give it some level of stability. And then quite a bit of interest these days right around the world, but particularly also here in Australia, around mass plywood panels as an alternative to some of the mass systems such as cross-laminated timber. And then look, there's a range of different strand products which are really interesting. I'm not sure how many of you have come across parallel strand lumber. This was interesting because this technology was actually produced in Australia back in the late 80s, a product called Scrimba. I don't know if many of you remember that one. It was produced by SATCO, the South Australian government, but we couldn't commercialise it here in Australia back then. And this technology went to the US, where it's now marketed as a product called Paralam, where these sort of great big engineered wood products are available. So basically crushed fibres all glued back together. There's also, in terms of the different strand lengths, 2 other products, laminated strand lumber, which uses more short wood type strands. And again, we're developing some of that technology in Australia here through a company called Lignor. And then there's a product that uses flaked oriented strand lumber. So 3 different strand type products, which are more used overseas, but I think we'll see coming into Australia over the next few years. And then in terms of our panels and bracing type products, obviously plywood is one we use quite regularly, but others you might not have come across, or you're starting to see, are things like oriented strand board. So again, sort of flakes of timber all laid up in specific layers to give a panel type product. And then obviously products with different types of particles, things like our particle board flooring, the yellow tongue, or the finer particle in products like hardboards and fibre boards. So looking at supply, that's quite interesting. We've probably got a fairly convoluted downstream supply channel that is includes both local production and imports. These days, in terms of how that comes to the market and looking at some of these applications where the product ends up, certainly with our detached 1- and 2-story homes, which where a lot of our timber goes, a lot of builders still choose to stick build on site. But the push really is across all of these type of applications these days to some type of prefabricated timber system supply. And so when we look at these again with our detached 1- and 2-story market, that can either be a residential builder, sort of stick building on site, but predominantly these days materials supplied from the frame and truss sector. If we're looking at different end user products such as industrial timber portal frames or specialty buildings such as schools or heavy timber post and beam structures for offices and things, that tends to come from specialty timber fabricators or the glulam manufacturers. Then as we move into our multi-res apartments, so the taller ones, 6 to 12 stories or more, that will tend to be supplied by the mass timber suppliers. And if we're talking about a lower level apartment that might be, say, up to 6 stories, where lightweight might be more effective, that can either come from timber frame system suppliers within the frame and truss sector or from specialty builders. So different ways these different products come to market. So quickly then, just sort of looking at some of the different products out there, we spoke about all these sort of individual products that you can get these days, but these days they're really supplied more as prefabricated systems. So if we're talking walls, by example, well, we often talk about this elemental prefabrication. So we could be taking a basic open prefabricated wall frame that we build most of our houses out of and in our townhouses, and we might start to add elements to that. So we could be adding the vapor barrier in the factory, we could be adding the windows in the factory, could be adding some sort of sheathing. And that just is sort of making it simpler, improving the productivity for builders in terms of the speed of construction on site. Or we could be doing fully closed prefabricated walls where you've got an external cladding and internal lining and maybe even electrical and plumbing walls can be supplied these days. Prefabricated cassette floor systems have certainly taken off, particularly in that townhouse market and apartment type markets, some of it in the domestic market. And what we're talking about here is a panel that typically fits on the back of a truck, so around 12 metres long, 3 metres wide. The real benefits are how quickly you can install these systems. So particularly for townhouses and apartments where you're getting repetition, very cost effective and speedy, and really does reduce that sort of risk of fall from heights for workers. So a really good OH&S benefit as well. In terms of roofs, we also obviously supply a lot of open roof trusses, both to the commercial and the residential sector, but there's no reason also why we can't do roof cassettes if we need to get that speed of construction on site. You see a lot of cassettes used overseas, particularly in countries that have short build periods, but we do certainly also see floor cassettes used in Australia, roof cassettes, sorry. In terms of supply of these type of systems, individual products will come from a wide range of local and manufacturers and importers. You see some of the logos here. In terms of the frames, they'll come through our frame and truss sector. We've probably got about 280 frame and truss fabricators nationally, and the 3 sort of major nail plate providers, Mytech, Multinail and Pride, all support them. And then we will often see a number of specialised suppliers that are doing a little bit more sort of volumetric and modular coming into the market. And there's a couple of companies just illustrated there. In terms of our mass wood frames, so particularly glue laminated timber, in effect, what we're doing here is taking small bits of wood, maybe finger joining them together to make them longer, gluing them together to make deeper. These days we can get glulam beams in Australia up to around a metre deep, so really quite substantial. I know Jeremy and Chris are both going to talk about this coming up, so I'll leave them to speak about their respective products. But in effect, there's a range of different glue laminated timber grades out there, and generally sort of that's dependent on the species they're made out of. In terms of supply of glue laminated timber, we have quite a range of Australian suppliers now. And as I say, Next Timber and Ash will be talking about some of their products today, and a range of different importers that all supply glue laminated timber now into Australia. Timber concrete composites is another really interesting area, and Chris is going to chat a little bit about a product that Ash is producing here. But in effect, what we're doing is, from an engineering perspective, trying to get the best out of 2 different materials. So when we do mass timber buildings, or sort of mid-rise timber buildings, one of the benefits of concrete is its acoustic performance because it's quite dense. So when we're doing those type of buildings, we can use a timber concrete composite to actually reduce some of that acoustic issue and control some of that vibration. And at the same time, we get the benefits out of the compressive strength of concrete and the tension strength of timber. So quite creative ways of mixing materials for the best application. In terms of our mass wood panel systems, the NCC describes anything over 75 millimeters thick as a mass panel. So that could include laminated veneer lumber, cross-laminated timber, nail-laminated timber, or dowel-laminated timber. And in terms of supply, we have 3 major manufacturers now producing CLT in Australia, which is great. So XLAM been around for a little while now, Next Timber, which is now in the market, and Jeremy will talk about that shortly. And then also CLTP Tasmania that produces a hardwood plantation CLT product. And again, a number of different importing companies from Europe and then more so these days from North America. So a range of ways you can get CLT today. So as you can see, there's a whole range of different engineered wood products out there at the moment for you to choose from. If you want to get some more information about all the different products, I'd certainly encourage you to have a look at WoodSolutions Design Guide number 46. This is freely available from the WoodSolutions website. Just grab that. It'll tell you all the types of products and where they're used, and has some great little sort of comparative span tables in there for some preliminary sizing. So that was a very quick introduction, and what I might do now is stop sharing my screen and hand over to Jeremy, and he'll send to you from there.
So I just want to quickly talk about market trends. So with regards to the CLT market, the US market is expected to double in the next 5 years. We've actually seen similar trends in Europe as well. So I think this is sort of emphasising the rise of demand for buildings with low carbon footprints. And there's also a bit of a growing demand for more advanced adhesives in this space. And we're starting to see some of these trends creep into Australia. So I'll just start by introducing sort of who Timberlink are. So we are primarily a softwood manufacturer. We've been in existence for about 10 or so years. We've got a plant in South Australia and in Tasmania as well. The next timber plant is actually just located just out of Gambia in Tarpeena. And we have distribution centres all across the sort of southern states of Australia, as well as some in New Zealand too. The products we primarily have sold to date have really been around the framing market. So we started off as a softwood framing business 11 years ago, and we started producing engineered wood products middle of last year. A lot of this the genesis for this was really around the responsibility for us to make best use of fibre and residues within all our timber products. And we actually commenced commercial operations of our wood plastic composite range in addition to CLT earlier this year. But I'll predominantly just talk about CLT for the remainder of this sort of brief presentation. So just to give some context as to who Timberlink are in a little bit more detail. So we're part of a portfolio of investment funds which sits under New Forests. So they own softwood plantations across Australia and actually across the globe. They've got about $10 billion worth of assets under their management, and we sit inside one of their portfolios. Inside that, we have our Timberlink organisation, and we produce softwood framing. And then from there, we actually, the odd bits of timber that we can't sell into the framing market, so odd lengths or which will have value grades, we sell them into Next Timber, and that's where we produce all our engineered wood products. So the reason where the actual sawmill is, it's actually located just outside of Mount Gambier. Very close proximity to that region there is actually what's actually in a region called the Green Triangle, which is prime growing conditions for plantation softwood. In that region there, they raise the seedlings in the nursery. They send them to the plantation where they're harvested after about 28 years, and then they move to the sawmill where they're processed. Some glitches here, Alastair. Okay, back up running now. Okay, so this is actually an image of our site, and you can see how close the actual forest is to the sawmill. At the front of the image there, you can actually see where the CLT and GLT plant is. Both products are produced inside that plant, but you can see that the throughput goes into the sawmill, and then the products there can make their way across to the engineered wood products plant. So let's run through quickly what a typical offsite timber project service model looks like. And this is sort of irrespective of which manufacturer actually makes them. So we provide market support. So we've got sales engineers out in the market communicating with architects and engineers and specifiers to help them with their projects. Then we move to a process of 3D modeling, which we do predominantly in-house. And we'll develop a bill of materials for all the products, including screws and fixings or anything other components that we're supplying with the project. We then move across to the manufacturing stage where we manufacture the goods. And then we also manage the freight and logistics to the site. And we use that via various connection providers or third-party distribution partners. The products that we actually manufacture, we can make products that are 16 meters, or CLT panels that are 16 meters long, 3.5 meters wide, up to 360 millimeters in thickness. We edge glue our boards. We actually sand all our panels. And then with our glue laminated timber products, we can make 12-meter long beams up to meter in depth. And we use feedstock width ranging from 65 millimeters to 135 millimeters. We actually then process them all through a planer, so they're all dressed all around. And we can provide them with or without RSs. As part of our service model as well, we also provide the fixings, brackets, components, and any other value-add items that the customer may want, which include things like temporary membranes, end grain sealers. I suppose the important point here to note is that all the offerings for what we provide may not be the same as what all other manufacturers provide. So they do vary from supplier to supplier, particularly the value-add components. But even some subtleties around what lamella thicknesses manufacturers use can vary, same as board widths, whether they edge glue or don't edge glue, what types of adhesives they use, what grades of feedstock they use, but also things like certification, treatment, chain of custody. Those are all variable within the supply chain. So I dare say that if you're engaging with any supplier, just really probe them and ask them on what the differences are between their products and what the competitors are, and make sure you're sort of comparing apples with apples. One key difference for us as a manufacturer is the technology that we use. So we use an adhesive, a melamine adhesive that cures under radio frequency. So that needs an energy input in order to actually activate the adhesive. So our press is a radio frequency press, a little bit similar to a microwave, but not quite. We lay the boards up mechanically, so multiple layers, could be 3, 5, 7, or 9 layers, and we alternate the direction of each layer, and we apply a layer of adhesive between each layer, and then that goes into the radio frequency press, and it presses them in section by section as the actual CLT panel or GLT beam moves along. This varies from supplier to supplier. Some use it, and it's all really dependent on what type of adhesive that they use. What we do from a technology point of view is we do have the ability to import models from third parties, or we have the ability to actually develop them in-house from engineering and architectural drawings. If we are importing, and this will be the same for most manufacturers, if they're importing from external models, they do tend to come with some challenges. The geometry is typically retained, but the translation of data can be a little bit clunky. So I dare say if you're going to go down that path and generate your own models, just to run some tests and trials with your supplier before you actually go down that path. It generally does require some rework and manipulation on the manufacturer's end. And this is typically due to things like tool assignment, tool limitations, and what can actually practically be machined. So there may be some changes that need to happen there. Most manufacturers will tend to prefer to at least do probably the last 50% of the detailing themselves. This includes things like putting in lifting points, looking after the loading drawings, any QA documentation. So if you are going to go down that path, I dare say be rigorous and get your scope right with your manufacturer before you actually go down that path. When it comes to compliance and things like that, generally speaking, if you're going into large commercial applications, you're going to need to have certification with regards to fire performance. So our products have been tested through Warrington Fire, and we've got test data to support both products that are wrapped in fire-rated plasterboard, so encapsulated, or bare, where they don't have any fire-rated plasterboard on them. So we've got test certificates for both of those. But the point there that I really want to make is that with the fire testing, not all things are created equal. So suppliers can't generally swap in one adhesive type or a better performing adhesive than for another one. They're usually set up to deal with one, plus they necessarily won't have the testing certificate to justify substituting one in or one out. So the adhesives that we use is a melamine adhesive, which means it doesn't actually degrade at heat. So it gives you in essence a product that won't delaminate as that fire gets through to that glue line, so it retains its glue line integrity. Also, the lamellar layups influence the overall fire performance, and those can also differ between supplier. So engage with your supplier and look at their test data and what they have to offer in that space. With regards to fire performance, as I said, we have solutions with our fire plasterboard. We also have DTS and performance solutions up to 3 hours. And we also have tested passive fire solutions with some supply partners. So really talking about fire collars and fire stopping solutions and things like that. Accessible via design guides and test reports and test certificates, all available on our website. So if anybody needs those, feel free to reach out and download from that space. And with regards to acoustic performance too, we've also spent a reasonable amount of time down at CSIRO in Clayton doing a whole bunch of testing with them. Acoustic performance is typically critical for residential type application. We've tested tens of different solutions in that space. They are available through our literature, so through our guides and that, but we've really focused on having expressed soffits for CLT construction. So there's some solutions available there. Also, WoodSolutions Design Guide 44 has a whole host of solutions available there, which are fairly generic and supplier agnostic. But one thing I want to talk about with regards to CLT is around some of the opportunities that really present itself in the market. So I started this presentation with a brief synopsis of what's happened in the US and the European markets with regards to growth in those sectors. But I think there's a real big opportunity in the Australian landscape to look at how do we actually leverage our existing supply chain. So we can use things like cross-laminated timber to partner with lightweight timber framing to build buildings that we would typically build in more traditional styles. And so in this example here, this is one out of Portland in Oregon. There's a whole host in the US. Lightweight timber frames, CLT floors, and it really is becoming the normal method of construction over there. So there's an opportunity there for the Australian market to really grab this and embrace this technology. So we can utilize the existing capabilities and abilities of the frame and truss market. We can also reduce the freight costs and CO2 footprint of building our wall frames closer to the construction site. We've got supply partners with regards to frame and truss manufacturers and the connection suppliers, the nail plates providers, etc. Those are all very, very well established in the Australian market. But we just need to pull it all together. Now we have 2 high capacity softwood CLT manufacturers in Australia. So this solution is somewhat supplier agnostic. They can already supply into this market segment. And we've got multiple frame and truss manufacturers very close to where the high density housing needs to be. So there's a real big opportunity there for this segment to sort of embrace what's happening overseas and bring it into Australia. So if I look at some of the past projects that we've done, as I said, we started producing CLT panels and glue laminated timber products middle of last year. This year we delivered one of our first projects, which was a residential project into New South Wales. So you can obviously build stairs, walls, floors, all those sort of assemblies using cross-laminated timber. And then we've also just recently developed or delivered a number of commercial projects in the throw of delivering a few more. This project here is quite interesting. This is one done up in Sydney. It actually had 3 timber suppliers on the one project. So ourselves were supplying the cross-laminated timber, Ash was supplying the glue lam, and Hein actually supplied some of the glue lam on the external facade. So we really played to the strengths of each of the suppliers to really collaborate together and pull together a really good outcome for the client. It also had factory applied membranes and some of those other value add items to really take a lot of that work away from the construction site. A lot of collaboration or service coordination was required for a lot of these projects, as they always are. As I mentioned before, there's the opportunity to pre-fit some membranes to do some value add and really manage that moisture on site. That's becoming a bit more prevalent these days with contractors being a bit more, really putting a lot of emphasis on protecting the timber. As a manufacturer, it includes the placement of pre-fitting temporary lifting solutions. So that's usually coordinated through the shop drawing process. And another internal image. Another project here I'd like to talk about too is a project up in Barangaroo, up in Sydney. And this one's really, the emphasis of this is really making the complex simple. So the project went through a bit of a journey, but it really was about pulling together a bit of a jigsaw puzzle. And it actually went together on site, relatively straightforward, but it required a huge amount of coordination through the design team and through the shop drawing phase in order to get that outcome. So that's one that we're pretty proud of. These are some of the panels that are going in. You can see the amount of machining that had to happen. We were actually able to apply some manufacturing principles in here to sort of streamline that, although it does look complex. We were actually able to simplify it. So that required, as I said, input from across the board. And same with lifting points, we had to coordinate that with the steelwork too. So a bit of a challenge there. This is another project that's going up in South Australia at the moment, a hybrid structure to some degree. It's got concrete, it's got steel, it's got CLT, it's got glue lam, it's got a whole host of different things in it. Has 2 timber suppliers on it, working on it together. So Ash are actually supplying the glue lam, we're supplying the CLT. Once again, another high level of coordination and collaboration on this piece of work, which we're all very, very proud of to work with. Some images there that we can see. Now, I mentioned earlier around making sure that not all suppliers are necessarily created equal, and this is some of the certification that sits in behind our products. So we have EPDs for our products, we've got declare labels, engineer EWPAA certification, fire certificates, FFC and responsible wood, and PFC chain of custody as well. So if you're looking at future building challenge, there's some of the certification there you need to support your application sits in behind that. We're also looking at some other certification, which we hope to announce at the end of this year too. So, and the other key point for us is regards to our sustainability. It's really at the core of what we do at Timberlink. So by all means, these are all accessible via our website if you want to download those and see what sits in there from an environmental and sustainability point of view. The credentials are outlined, so I encourage people to download that. If you've got any questions or any queries, by all means, feel free to reach out to myself at Timberlink, and same with Luca Brown as well. He's our technical sales engineer. And if you've got any questions, post them in the chat, and I'll be happy to answer. So thanks.
Hi everyone. Thanks for making the time today, and for WoodSolutions for hosting us. Very generous. So my name is Chris Gilbert. I was the founder of Archer, an architecture practice, and then Kanda, who is an offsite manufacturer. But recently I've joined Ash as head of architectural solutions because I was just really excited about the work that they're doing in this space. Like, I honestly believe we need to decarbonize by 2030, and the only way we can do that is if we start transitioning to mass timber away from concrete. And you can see some of those great examples of the collaborations that Ash is working with Next at the moment. And like, I really feel like those people who are committing and investing time in changing the way we build are really pioneering, are really leading the charge. And yeah, I'm really grateful for other architects who are picking up that mantle. So today I'm going to talk to you about MassLam and ATC, two super exciting building solutions that integrated together produce kind of start to bring craft and ornamentation back into a lot of the buildings. So Ash is Australia's largest vertically integrated hardwood manufacturer. We have 6 full-time design engineers who are available to scheme up and price your jobs early in the process. So rather than you designing something, sending it to the QS, and the QS coming back and telling you it's over budget, we can actually get in early. We can give you some rough ideas of how large the members are going to be, and actually provide you a price straight up front. We also have our own robotic CNCs, so 3 Humdiggers, a new one, a Robot Max, which is very special. I encourage you to come out to the mill and have a look at it. It's can unleash a lot of opportunity, let's say, for architects. We are also responsible wood certified and PEFC certified. So just for context, this is Ash's mill. From this car here to the end of this lot, that's almost 1 kilometre for scale. And all of the sawdust that we produce from machining elements for like staircases and profiles, also all of the sawdust from our 3 machines, our robot drives through here, here, and here, is diverted back, and we use that sawdust. We actually burn it and then use it to generate power to power our kilns. And that saves us with about 80% of our power comes through that use of on-site material. This is our green mill where we're bringing in the plantation timber from Tasmania and racking and stacking it. We have to keep it wet prior to sawing, but just these images just give you an understanding of the kind of scale that we're operating at. This is a mill down in Tasmania that we source our timber from. So this mill, the owners are investing heavily in upgrading the plant here because currently we're shipping full logs from Tasmania to Victoria, but the ideal situation is to source sawn logs. So currently we're running about 30% wastage because we're bringing full logs. When we start bringing that into planks, we'll drive that efficiency right up. The reason why we source material from this mill is because the plantation timber is actually located around in the north of Tasmania and the northwest of Tasmania. So it's ideal, it lowers the carbon miles from plantation to mill. And then in future, we hope to be able to use this train line to actually ship that bulk material up to the boat. I also throw in this image because I think certifications are great, but I think it's also important that we have a real connection with where we get our timber from. So this is the plantation timber, the Eucalyptus nitens down in Tasmania. These trees were originally grown to turn into pulp, to turn into paper. So when I was actually studying up at Launceston at the time, and it was quite contentious, this idea of growing this timber just to turn into pulp. So Ash has spent 10 years figuring out how to cut and dry and glue this timber back together to make a kind of structural grade product, which is a great use case because if Ash aren't purchasing this timber, the next biggest purchaser turns it into wood chips, and then the people who are lower down in the chain than that actually turn it into shipping crates, which is really devastating. But I'd encourage anybody who's interested, anybody who's got a client who wants that kind of full supply pipeline transparency to come down and visit our forests with us. We're more than happy to kind of host them, take them out for a walk, etc., etc. We can even have lunch out there, be delightful. This is one of our K2 Hundigers. So this is over 30 meters long, this machine. It's really great at doing these kind of more, well, I'm going to say simplistic, but traditional kind of post and beam connections. We also have a new saw, which is a Robot Max that really lets you unleash a lot of complexity, which is quite exciting. So the products that we will talk about today, so Masslam 33, that's just finger jointed plantation oak laminated together. 38 is where we laminate in one direction, then the other. We use that for columns and beams. 33 we use for rafters and purlins. And then ATC is when we're combining all three things. And so 38, 33, and concrete to create a hybrid system. So just a quick background of the projects that we've delivered with Ash that have used 33 and 38. So this the Bendigo Gov Hub. This is a great project by Architectus, Macquarie University, Westfield Knox. And then just some of, I thought I would show some of the work that I've done with Ash. So this is a project called Off-Grid House. All of this is Masslam. Rob Nesting was the engineer on this, really fantastic engineer. And just like absolutely understood how to use timber in the best possible way. So this member here is in tension. It can be quite thin because it's getting held up by these members. intention, and really just like Australian timber at its best. So fans timber composite, I could talk all day about this. I'm quite excited by it. So this is a fully fire tested solution. We can build up to 12 levels and expose all of the timber, and it's carbon neutral. And the timber that it is using, it has been upcycled from a plantation forest. So there's all good news stories. So this is how it looks in the end. As I said, up to 12 levels. It's really traditional kind of post and beam construction with exposed joists. But what we do is we supply it as panels, 1800 wide, with plywood on the top. And then we use shear connectors to attach a really lightweight mesh to the top of that, and then just pour 25 MPa concrete over the top. And what that does is the concrete provides acoustic and fire separation. So you can get up to 120 minutes fire separation between the floors with 120 millimeters of concrete. And what it also does is it ties all of these joists together and creates a diaphragm action. So you can tie your floor slab back to your lift core, and it removes the need to kind of have bracing in the facade, which I love bracing. It looks great, but it's just quite expensive. So this kind of minimizes that step. What I also quite like about the solution is it allows you to run surfaces over the top of your primary beams through here. And I'll show you an example later of a project in Tasmania that's been there for 200 years. And this kind of like designing for adaptation, I think, is really critical, because not only do we need to reduce carbon going into buildings currently, we need to think about how those buildings will be used in the future. And I think this provides future clients with those opportunities. So again, the system works by the concrete acting in compression and the timber acting in tension, all tied together through that lightweight mesh. So you can ship these panels to site without any of the shear connectors. So we can stack them relatively efficiently. And then once they're on site, the installers will fix the shear connectors, lay the mesh, and then we can pump in the concrete screed later. You don't need to prop underneath this before you pour the concrete. So you can stage your building however you like. You can go up multiple levels and then come in with a pump truck and fill the screed, or you can go half of your building left, right, if that makes sense, and kind of work your way up, or with visual grade fully exposed. So where this comes into its own is when you need to get larger and larger spans. So we can do a 9 by 9 meter span, or 8.4 to 8.4 to kind of match the car parking grids. And that reduces the need for a kind of transfer slab from your concrete to timber section. So obviously service class 1 and 2 only, we can't do fully exposed, but we can provide solutions where we ship the columns or beams with a wrap, and then you can clad over the top. And then lastly, all of our timber is formaldehyde free. When it gets into connections, there's a few different options. Obviously, simple supported is the most efficient, and that's what the images you've seen. And that's where we just land the joists on top of the primaries, and you can run services over the top. That's great. It's really efficient, but your floor to floors are higher. So when you start looking at residential and you've got that 3.2 meter build up or height limit, floor to floor, let's say, or constraint, maybe this isn't so feasible. So what we can do is we can semi-notch the joists into the primary. So that still gives you the ability to run some services over the top. Generally, you can run your duct for your range hood, that's 70 mil, 300 mil wide, duct over the top, because these are obviously at 800 mil centers. So you have 600 mil clear in between. But again, if you're still not hitting your floor to floors, we can put the members completely in line. So that allows you to tighten everything up a little bit more. We can notch the top of these primaries slightly to get some services through, so like electrical conduits, et cetera, but obviously it just needs to be considered. And that's why we encourage you to reach out early to the engineers and myself, and we can kind of help you work through those kind of things. Here's an example of that kind of really simple bearing connections and quite traditional kind of build up. This is the project that I was talking about earlier. So this is in Salamanca in Tasmania. It's 200 years old, and I include this because this solution isn't new. It's extremely, extremely traditional, and it's important that we start bringing contractors on board early and talking to them about that as a way to kind of de-risk it, I guess. Like this is extremely conventional. We've just done additional fire testing, et cetera, et cetera. It's essentially exactly the same as this, but we've poured a concrete screed over the top. What I also like about this is that this was built by convicts and their tools were constantly breaking, so they had to dumb down all of the connections. The humdiggers that we import from Germany, like that tooling doesn't work very well on our Australian timber either. And these connections, we've kind of gone for a really quite simplistic connection detail. So simple bearing connections. And the engineers worked quite hard to make this work. So this, rather than a plate connection, a fish plate, our energy now is going into making these simple bearing connections, where with about 60 mil, you can land this column on top, and after a fire event, you still have 30 mil of capacity. And these tie rods tie through here and across the top, as shown in this drawing. And these, why we like this is it uses Australian timber to its full capacity. Australian timber, it's denser, so the char rate is lower. So you can use this a really small bearing connection to transfer the load of this beam through to the column without a fish plate. Which is what I like about it is it kind of is a nod to the Australian timber and is also super efficient. Here's some cost comparisons of, fish plates. You're looking around $1,800 per connection versus a simple bearing connection, which is around $500. So this is where some of the European suppliers might be cheaper for the fiber, but we can kind of use like those Australian qualities to kind of pull back some of that cost and deliver a kind of more local solution. So I thought I'd include this project at the end, just because it's a great example of not ATC, but just timber building in general in Melbourne, but also the hybrid between mass timber and or mass lam, so ashes, post and beams, and CLT. So there's 15 stories in total. The bottom 6 are concrete and the top 9 is timber. And what that allows you to do is, I guess, gather data from collecting that bottom, the construction, gather data on the construction of that bottom building and the data on constructing the top building. So just by shifting, the team ran a comparison design where it was full concrete, and just by shifting the top building to timber saved 34% carbon. What is also interesting is on-site works. So for the lower 6 levels, there was 54 to 58 workers on site every day, as compared to the top 9 levels where it was 14 to 18. I was also talking to the architect the other day, Chris, and he was saying out of the 54 to 58 concrete workers, there was not one female, but almost half of the timber team were female. So there's this opportunity for a cultural shift to occur at the same time, which I think is like really fantastic. There's an ingrained culture in concrete, which keeps it quite masculine and toxic, where the timber engineers who worked on this project said they've never had a kind of more considered and curated project than this one. And it was because there was new people in the field, and it hasn't obtained a kind of cultural narrative, I guess, masculine cultural narrative. Was also interesting as fines, like 0 council fines compared to the concrete of 21 fines, and just the cycle time was much faster. So yeah, thanks for your time. Again, you can reach me at Ash, or we can chat afterwards.
Thanks, Chris. To share my screen again here. So we'd love to get some questions from the audience. If you've got questions for Jeremy or Chris or myself, we do have one question here just to get underway. Probably for either of you, Jeremy or Chris, but Kieran mentions one of the difficulties structural engineers have often is manufacturers not releasing their data sheets or design guidelines. What's your thoughts on that, guys? I think you're pretty keen to share as much as possible as you can, and certainly that sort of early supplier involvement is something I imagine you're all very much encourage.
Absolutely, I'd be more than happy to. It's what our data's on all in our design guides. I'm more than happy to release it. It's now been incorporated into engineering design tools like CLT Toolbox, so that's accessible there too. So by all means, if there's anything that's missing that people want, even our fire test data is available. So by all means, if people want to access it, we're more than happy to release it. So
yeah, likewise with Ash. And I mean, we even go as far, I mean, also, Jeremy, you also offer this, like, to come to give you tours of the facilities and actually go out and understand how we're processing the timber, what to watch out for, because I guess there's things that those design guides, although they seek to cover everything, because it's a technical document, you always miss some of the nuance or potentially some of the opportunity. And that's why I really encourage architects also to come out to Ash, because when you see the capacity of the machines and their capability, different types of designs become feasible in your mind, not just like straight post and beams. Like, these things are really agnostic towards complexity, and until you kind of see them in action, it's hard to appreciate that. So yeah, no, we're keen to, engage with engineers and architects as much as possible and provide you with whatever you need.
Yeah, I'd second that, Chris, 100%. So I've always found that when we've taken people to the forest or to the nursery and they've had that experience out there, and then we take them to the sawmill and then we take them to the plant, it's a bit of a light bulb moment for a lot of people. And I think particularly when you're talking about offsite manufacturing and machines and machinery, yes, those machines can do a lot of things, but they also cannot do everything either. So understanding the limitations of what that machine can practically do in order to have an efficient design is just as paramount as the technical component that goes into the actual engineering design. So understanding the manufacturing, and you guys are actually coming out to our factory in not too far away to have a squeeze. So getting that collaboration across industry and amongst peers and across other parts of the design community is absolutely important. And I mean, that's the only way we're really going to sort of move the needle. So it's really the timing to come into this industry right now is a really exciting time, and I think we're on sort of the precipice of some really amazing things happening.
Thanks, Jeremy. And Heather's just asked, can you see these systems like the cassettes and prefab panels being available for single dwelling construction anytime soon? I might just answer that one, Heather, because we do a lot of work with the frame and truss sector who supply into that single dwelling 1 and 2 story market. And absolutely, certainly things like floor cassettes have a benefit where you got to get a lot of repetition. So that's less so with a single dwelling, but definitely we actually developed the floor cassettes originally for ground floor cassette construction, because on sloping sites and flood prone zones, concrete really isn't a good sort of option for the consumer in any way. And what we were doing when we developed the cassettes initially was to give a sort of timber supply option similar to what the concrete guys do for the lightweight area. And definitely there's a number of different builders that, some of them like to stick build, some of them like to do open frames, but there's certainly others that certainly see the value in sort of panelized and prefabricated systems, effectively to build the house quicker so they can build more in any 1 year. There's also a question here, Chris, from Masood, just asking about, says, have you designed for multi-story facades, or you're limited to only one or two levels? I think you certainly would do multiple levels with your systems.
Yep. The structural system isn't limited to height. I mean, we did a competition in Sydney that I think it was at about 56 stories, with the top 12 stories being completely timber. But the actual facade system externally, I'm pretty sure, because of the fires in the city, can't be flammable, made out of anything flammable over 3 stories anymore. So often we're just using a curtain wall system, like an aluminium curtain wall system on the outside, or having timber structural mullions with an aluminium glazing adapter on the outside, so the glass is external. Yeah.
Well, gentlemen, we're just on midday, so I want to thank you both very much for fantastic presentations today. I'm sure the audience got lots out of that, just as I did. I just remind those in the audience that if you want to actually re-look at the presentations, or if you enjoyed it and want to let your colleagues know, they are all recorded. So this presentation will be uploaded probably in the next couple of days. So have a look there. We're doing another webinar in 1 month's time. This will actually be on the 1st of October, and we've got Michael Lee from CUSP, who I mentioned earlier on, talking about Tasmanian timber products, beautiful, sustainable and available. So certainly encourage you to come on board for that one. So thanks everyone for attending today. It's been great to speak to you again, and hopefully you can join us again next time.